Hello! In this video, we present the retrosynthesis of deuterated vonoprazan, a labeled compound that can be useful in researching the pharmacology and metabolism of the drug, as well as an internal standard for bioanalytical methods. In general, this retrosynthesis considers the tri-substituted pyrrole ring as a retrone, and each of the substituents is disconnected until reaching the raw material's pyrrole, orthobromofluorobenzene, and per-deuterated dimethylformamide, as we will see later on. The retrosynthesis begins with a carbon-deuterium disconnection to generate imine-2 and the deuterated reducing reagent, sodium borodeuteride. Intermediate 2, in turn, through a carbon-nitrogen double bond disconnection, generates aldehyde 3 and deuterated methylamine 4. Sulfonamide 3 is considered a retrone, and based on a sulfonation reaction, through a nitrogen-sulfur disconnection, it yields pyrrole 5 and pyridyl sulfonyl chloride 6. It is worth mentioning that the retrosynthesis of this intermediate was already presented in a previous video on the retrosynthesis of unlabeled vonoprazan. The fluorophenyl group in compound 5 can be incorporated into the pyrrole by a Suzuki reaction, having a bromine at the required position. With this idea, a carbon-carbon disconnection in 5 generates bromopyrrole 7 and boronic acid 8. Based on a regioselective bromination reaction, a carbon-bromine disconnection is applied to 7 to yield the monodeuterated formal pyrrole 9. Protecting the pyrrole nitrogen yields the protected pyrrole 10. The deuterated formal group can be incorporated into the pyrrole ring using the Vilsmeier-Hock reaction. With this idea, a carbon-carbon disconnection at 10 produces per-deuterated N-dimethylformamide 11 as raw material and the protected pyrrole 12. Deprotection of pyrrole 12 yields pyrrole 13 as raw material. The boronic acid group in 8 functions as a retrone, and a carbon-boron disconnection in 8 yields orthobromofluorobenzene 14 and isopropyl borate 15 as raw materials. In summary, here are the disconnections. The following video will present the resulting synthesis.